Assalamualaikum and a very good day to everyone. So let's start with our very first topic for the semester, which is topic 1 entitled Matter and Stoichiometry. So these are the subtopics that will be covered in topic 1. So we have 10 of them. I'm sure most of the subtopic, as you can see here, okay, so most of them have been introduced to you during your SPM time. Okay, so this could be advantages to you if you plan to score this topic later on. Okay, okay, subtopic 1.1 atomic structure and subatomic particles. So we have one learning objective for this subtopic, which is make sure that you are able to explain the structure of atom and the properties of subatomic particle in terms of their relative charges and relative masses. Okay, so for your information, uh, for every subtopic, will have its own learning objective. So learning objective help us to keep track on what we need to achieve at the end of the subtopic. Okay, it's like your checklist. So that would be your guide, okay, in order to know what needs to be covered for for every subtopic, for each subtopic that we have. Okay? Okay, so 1.1.1, the atomic theory. Okay, so atomic theory is a scientific theories, okay, a scientific theories on the nature of matter. Okay, on the nature of matter. So this atomic theory has been put forward by a scientist, okay, who's also a physicist and a chemist, okay, known as John Dalton. Okay, so John Dalton has postulated, okay, five postulates. Okay, postulates can also be known as assumptions. Okay, all right. So based on John Dalton's, he stated that matter consists of tiny particles. So this tiny particle is known as atoms. Okay, and then secondly, we have atoms are indestructible. So atom cannot be destroyed. Okay? It cannot be destruct. It can be converted into, for example, molecule, but then again, it cannot be destroyed. The third postulate is all atoms are identical in mass and other properties. Take, for example, we have oxygen atom. Okay, so all oxygen atom should have the same mass and also other properties. Okay, the fourth postulate we have here is opposite to the third postulate. So it says here atoms of different element differ in mass and other properties. Okay, so take for example, we have oxygen and hydrogen. Okay, these are two different atoms. So by right, they should have different masses and also other properties. They should differ in terms of mass and also other properties. Okay, the last one is when atom of different elements combine to form a given compound, the constituent atom in the compounds are always present in the same fixed ratio. Okay, when two or more atoms are combined, okay, different element combine when this atom combine to form a given compound. Okay, the constituent atoms in the compounds are always present in the same fixed ratio. Okay, let's have H2O. Okay, for H2O, we have, this is water. Okay, for H2O, we have two hydrogen atom and one oxygen atom. Okay, when these atoms combine, it forms water. Okay, it forms water molecule. So for water molecule, the formula unit, the chemical formula will always be two hydrogen and one oxygen. That is what it meant by same fixed ratio. When we are talking about H2O, okay, the chemical formula will always be two hydrogen and one oxygen. Okay, all right. So this is the structure of the atom. So we know that atom comprise of nucleus and electrons. Okay, the nucleus comprises of proton and neutron. So a proton has a positive charge of uh, this symbol. Okay, we can represent positive charge as this, and electron has a negative charge of uh, this symbol. Okay, uh, and neutron, on the other hand, has no charge. It is a neutral particle. Okay, so we have only for the nucleus, we can only have protons and neutron. Okay, so this nucleus, as you can see from the diagram that we have here, the nucleus is located at the center of the atom. Okay, so in the nucleus again, we have proton and neutron. But for electron, it is located outside of the nucleus. Okay, it is located outside of the nucleus. So we cannot find electron in the nucleus. That's what we have here. Okay, so we have proton and neutron in the nucleus. Electron, on the other hand, uh, can be found in this region. Okay, in fact, we do not know the exact location of the electron. It's not like our solar system. Okay, electron does not orbiting the nucleus. Okay, so this is not the case lah for electron. Okay, it's not orbiting the nucleus. But what we know is that the electron can be found outside the nucleus. Okay. All right, so next will be 1.2, atomic number, mass number, and isotopes. So these are the learning objective for the subtopic. Okay. So this is how you represent the elements, the atoms for the elements. Okay. So earlier on, you have been introduced to atom. So we know that atom is a fundamental unit or basic unit of matter. Okay. Then next would be how to represent, or how do we represent the atom. Okay, so to represent atoms, we could use this standard nuclear notation. Okay, so standard nuclear notation is consists of a chemical symbol, okay, as what we have here, symbolized by X. And then we have Z. Okay, Z stands for atomic number or proton number. Okay, proton number. Atomic number is equal to proton number in the nucleus. And then A here we have mass number. So this mass number actually represents proton plus neutron. Okay, why is it called mass number? Okay, because the mass of the atom mostly contributed from the nucleus, from the mass of the nucleus. Okay, so for your information, electron is the lightest particles uh, compared to proton and neutron. Okay, so major contribution of the mass for that atom come from the nucleus. That is why the mass number only includes proton and neutron, which in this case we can call it as nucleus lah. Okay, the component of the nucleus. So basically, the nucleus, the mass of the nucleus represent the mass number of that atom. Okay, so we can total up proton and this is proton or atomic number plus neutron. Okay, this is neutron and stand for neutron in order to obtain the mass number. Okay, moving on. Okay, this is example. For neutral atom, the atomic number is also equal to the number of electron. Okay, take for example hydrogen. Okay, please take note on this. Okay, if it is a neutral atom, then the number of proton, the atomic number is also known as number of proton, is equal to the number of electron. Okay, so we know that proton is positively charged, electron is negatively charged. When these two have the same number, number of particles, therefore we will get a neutral atom. Okay, there is no charge for that atom. Okay, so hydrogen, so this is a symbol of hydrogen, and then we have atomic number at the bottom, or proton number, which is equal to 1, and then at the top here, at the top left hand corner, represent the mass number. Okay, so neutron for hydrogen is 0, and proton for hydrogen is equal to 1. Okay, so since this is a neutral atom, therefore the proton number is equal to electron number. Okay, if it is an ion, the number of electron do not equal to the number of proton in any element. Okay, ion means the atom, okay, is no longer neutral because it accepts ataupun it gains electron, or it lost electron. It lost its electron. Okay, if it gains electron, it become negatively charged ion. Negatively charged ion. Okay, all right. If it gain means accepts, if it donates its electron or loss of its electron, okay, it become positively charged ion. Okay, so how do we represent this ion? Okay, so we have magnesium. So magnesium can be represented by using Mg. Okay, all right. So the mass, we have mass number and atomic number for the element. Okay, so this right here dekat bawah ni will always be proton number or atomic number. Okay, will always be proton number, regardless. Okay, regardless whatever regardless the number of electron is. Okay, regardless the number of electron is, the proton will remain constant because we do not donate proton or we do or accept proton into the atom. And then this is a mass number. So for magnesium, the proton is equal to 12. Okay. The electron, on the other hand, because it has charge here, okay, it has charge 2 plus. That means it donates, okay, it donates its 2 electron. Dia buang 2 elektron dia. Okay, that means it has lack of electron, or it become more positive. Okay, so the number of electron now is 10 electron. As for the neutron, for magnesium, it has 12 neutron. Okay, so to find out the mass number, we can simply total up the neutron, the mass number, which in this case, it is Z. Is it? It's A, sorry. Okay, it's A. So 12 plus 12 is equal to 24. This is neutron, this is proton. Okay, all right. So do not forget the charge. Okay, to represent ion, you need to have the charge. So the charge is equal to positive 2. Why it is positive 2? Because the electron is no longer the same as proton. Okay, if it's neutral, then it should be the same. Now it has lack of 2 electrons. So that's why the 2 plus represent that the electron has been removed from the atom. Okay? Okay, isotopes. Isotopes are atoms of an element with the same number of proton but different number of neutron. Okay, when the number of neutrons are no longer the same as the number of proton, of course, it will affect the number, the mass number. Okay, the mass number will be different. So this is the definition of isotopes. Take for example, so we have uranium here. Okay, so uranium, as you can see, the mass number is at the top here, at the top of the atomic number. Okay, so both of them are having different mass number. This is due to the number of proton, due to the different number of neutron. Sorry, the different number of neutron. The proton, okay, will remain constant. It will not change. Okay, proton is like what I would call the DNA of an atom. Okay, the DNA for an element. So it will not change even though the number of neutron or the number of electron are changed. Okay, so the number of proton will remain constant because when from the number of proton we will be able to determine what is the element, what element it is. Okay, so imagine if we are based on number of electron. Okay, if the number of electron change, therefore it will no longer be the same element. Okay, that is why isotopes, the definition of isotope state that the number of proton remain constant, but they only differ in terms of the number of neutron, or in this case, the mass number lah. Okay, the mass number will be different. So proton will be constant. Okay, atomic number. Okay, so we have here the number of proton is equal to 92 for the first isotope of uranium, the mass number of this uranium is equal to 235. So we can find out the number of neutron. Okay, so the number of neutron in this case, so you need to minus, tak kira pula, okay. 235 minus 92 is equal to 143. Okay, neutron. As for the second isotopes of uranium is 238 minus 92 is equal to 146. Okay, neutron, neutron 146. Okay, so we have all the details here, the proton number and the mass number, the atomic number and the mass number. So we can minus these two to get the number of neutrons. So as you can see, the number of neutrons for both isotopes are different. Okay, so this is what we call isotopes to each other. Okay, so this is a checkpoint. So you need to complete this checkpoint. Find the number of protons, electrons, and neutrons for oxygen. Oxygen 16 and oxygen 17. So proton for oxygen ataupun proton or atomic number. Okay, sorry. Okay, it is stated here that find the number of proton, electron, and neutron. So number of proton is equal to, so please remember that do not confuse which one is which. Okay, the bottom one is the proton number. Okay, the upper one represent the mass number. Okay, so proton is 18. Electron, number of electrons, since both of them are neutral atom, therefore, okay, the number of electron is also equal to 8. Okay, for this is for oxygen 16. Okay, and then the number of neutrons is equal to 16 minus 8, which is 8. Okay, mass number minus the proton number. Okay, now let's do for oxygen 17. Okay, so proton number is equal to 8. Okay, so when we see proton number, we will automatically know that this element is oxygen. Okay, this element is an oxygen atom based on the proton number. Okay, electron is also 8, and then neutron is 17 minus 8 would be 9. Okay, all right, question number 2, complete the table below. X is not the actual symbol of the element. Okay, so we have the X as a symbol, and then we have the charge, 2 minus. So 2 minus, uh, 2 minus indicates, okay, 2 minus indicates that this atom accept electron. Okay, that means the ion has extra electron. So we know that electron, the charge of the electron is negative. So since the atom now has more electrons, so it becomes negatively charged ion. So the number of electron by right should be more than the number of proton. Okay, all right, so we have electron here. So 16, do not forget that you have to total up the proton, okay, number of electron. 16 is the number of proton, okay, ataupun the number of electron if it is, okay, if it is in a neutral state, okay, without the additional electron. So 16, now they're becoming ion, it become 16 plus 2 is equal to 18. Okay, whereas proton, we can get straight away from the atomic number, which is 16. And then for neutron, okay, we can minus 34, the number of the mass number minus the atomic number, which is equal to 18. Okay, All right, so that is for question number 2. Now let's discuss question number 3. Okay, W2 plus ion, okay, has 20 electrons and 20 neutrons. So this is the information given for W2 plus, while G minus ion has 20 electrons and 19 neutrons. Okay, so we have two information there. Write a complete symbol in the form of X for atom W and atom G. Okay, so you need to write the nuclear notation for atom W. So it has specified there, okay, it needs to be in the form of atoms, not in the form of ion. Okay, all right, so let's go for W first. Let's discuss the answer for W. W, okay, we need to have the mass number and also the atomic number. Okay, all right, so we need to have A, Z, and then, yeah, we need to have A and Z first. Okay, so the mission is to find the proton number. Okay, proton number, or you can also find, either way you can find which one first, doesn't matter. Okay, I would like to find the proton number first, the atomic number. Okay, tak kisah pun. Okay, W2 plus is in the form of ion, so don't forget that it has 2 plus charge. Okay, that means it has donated, okay, it has donated 2 of its electron. When it donates the electron, okay, the atom is now has less electron, so it become more positive. That is why we have the positive charge. Okay, all right, so in order to know proton number, we cannot base on the electron here, because this electron is for the ion, not for the neutral atom. Okay, all right, so we have to total up, we have to total up 20 electron. Okay, we have to total up 20 electron plus, okay, plus the 2 electron that has been donated. Okay, so this is the number of proton. Okay, so the proton number is equal to 20 plus 2, which equals to 22. Okay, all right. So in neutral state, remember that in neutral state, in neutral atom, the number of proton is equal to the number of electron. So that is why we have to include the charge here. So 2 represent the charge. 2 plus 20, this is the number of electron. This is the number of electron if it is neutral. Like I said just now, if it is neutral, the number of electron is equal to the number of proton. So there we have the number of proton, or the atomic mass. Okay, the atomic mass. So W, and then we have 22. Okay, all right. So once we have the information on the proton number or the atomic number, okay, we can just simply total up the neutron and the proton number, which is equal to 42. Okay, all right. If we were to write the complete symbol for the ion, okay, for the W ion, so how do we write it? Okay, it's gonna be like this. So it's gonna be the number of proton will be the same. Okay, regardless if it is in neutral state or in ion state. Okay, it will always be proton at the bottom, and at the top it will always be mass number. Okay, all right. The proton plus neutron does not involve electron at all. Okay, but This is for the ion, right? So if it's an ion, therefore you have to include the charge. So this is how the what do we call that, the nuclear notation of the atom, and this is the nuclear notation for the ion. Okay, so the same approach we apply for G. Okay, so what is the answer for G? Okay, so G is equal, this is the nuclear notation, so we have 38 as the mass number and 19 as the proton number or atomic number. If we were to write the nuclear notation of the ion, the G ion, then it will become 38, 19 G minus. Okay, so this is in a form of ion. All right, so we are done with that. Okay, next, let's move on to chemical formula and IUPAC nomenclature of compound. Okay, so just now we have learned on how to represent the atom. Okay, how to represent the atom of an element. So we have standard nuclear notation to represent that. We have standard nuclear notation. Okay. All right. So the learning objective for this subtopic is make sure that you are able to write the chemical formula and IUPAC name of a given compound and vice versa. Okay, so nomenclature stand for naming, systematic naming for a compound. Okay, so this is the like I said, systematic naming of compound. Okay, based on IUPAC. IUPAC stand for International Union of Pure and Applied Chemistry. Okay, this is the body that controls anything related to chemistry lah. Okay, so this is apa nama tu, whatever that is related to chemistry, okay, we need to be based on IUPAC, especially the naming. Okay, so nomenclature means systematic naming based on IUPAC. Okay, so we can divide the naming of a compound based on the type of the compound itself. So we have ionic compound and molecular compound. Okay, so the naming can be divided into two, ionic compound and molecular compound. Before we could go further, you need to know how do we identify whether it is an ionic compound or molecular compound. Okay, so I'm sure you are already familiar with ionic compound. So ionic compound is actually made up of cation plus an ion. Okay, so some of you may define ionic compound as metal is made up of metal and non-metal. Okay, it does not necessarily, the cation does not necessarily be a metal. Tak semestinya. It can be polyatomic anion, which will be covered later, okay, in the slide. Yeah, it's supposed to be cation and an ion. Most of the time, the cation come from metal. Okay, most of the time. Anion come from the non-metal. Okay, whereas for molecular compound, okay, it consists of non-metal plus non-metal. Okay, this time around we can specify, okay, the non-metal and the non-metal. We can specify it as non-metal. Okay, so both all the components in the molecular compound need to come from non-metal element. So these are the two significant difference between ionic compound and molecular compound. Okay, for ionic compound, we have two naming style. Okay, so it depends on the metal itself, the cation. It depends on the cation. So the cation, which come from the metal, okay, can be divided into two, which are first the metal that has invariant charge. Invariant means the charge uh, is fixed. Okay, so it is not uh, changing. It will be a fixed number. Yes, that's the word that I was looking for just now. So opposite to invariant charge, okay, this is fixed charge. Okay, opposite to invariant, we have variant, okay, variable charge. So this is opposite to fixed charge. So dia apa tak fix lah. Okay, it change. It can be changed to apa another charges. Mostly the metal come from the transition element. Okay, so this variable charges metal most of the time come from the transition element. Okay, so this is the overview of the nomenclature on how to name a compound. Okay, so you need to differentiate the compound, the component of the compound itself before we could go to naming the compound. Okay, so let's start with ionic compound first. Okay, maybe we can look at the boxes that we have here. Okay, so we need to name the cation first. Okay, the first name will be from the cation, which again most of the cases come from the cation come from metal. Okay, so name the cation based on the metal's name. Okay, based on the metal. So name metal cation first, then followed by non-metal anion as the second name. For the second name, which is which come from the anion. Okay, obviously the anion come from the non-metal. So the non-metal, you need to change the suffix. Suffix is the ending of the term. Okay, so take for example, we have chlorine, right? So chlorine is the name of the atom. So the base name of chlorine is chlor. Okay, so when we replace the INE with IDE, so it will become chloride. Okay, so that is how you name the second name of the ionic compound, which represent the anion. So we need to change the ending to IDE. Okay. So this is for invariant charge, guys. This is for invariant charge. Okay. Right. So these are the examples of metals that are having invariant charge. Okay, as you can see, we have lithium, sodium, potassium, rubidium, cesium. So all of these come from group 1 based on the charge that we have here. All of them are having positive 1 charge. Okay, are having the positive 1 charge. So this is lithium, sodium, potassium, rubidium, and cesium. And we also have metals from group 2, which considered as invariant charge as well. Okay, so all the members in group 2 will be having positive 2 charge. Okay, so this is what we call invariant charge lah. It can only have one possible charge and it cannot be changed to the charge will remain the same. Okay. Yeah. Name of metal cation is the same as the element name. So the cation will be referring to the name of the metal. Okay, we don't have to change anything to the the name of the cation. Only for the anion, okay? All right, so just now is the cation. Next, we have the anion. So how do we name the anion? So naming monoatomic non-metal anion. So we know that anion come from non-metal, okay? Monoatomic means it consists of only one atom. Okay, it consists of only one atom. So how do we name them? So we can determine the charge from the position of the elements in the periodic table. Okay, all right. Like for example, group 17. Group 17 will have -1 charge. Okay. So to name an ion, change the ending on the element name to IDE. So like we have discussed earlier, okay, we need to change the ending to IDE. Okay, so we know that nitrogen come from group 15, right? So in order to form or to become stable in terms of its electron configuration, it need to accept another 3 more electron. Hence the 3 minus. Okay, so nitrogen is the base name. So when we change the ending to IDE, so it will become nitrite. So this is what I meant by monoatomic just now. As you can see, only one atom is present. Okay, opposite to monoatomic, we have polyatomic. That means we have more than one atom in the ion. So we have phosphide that come from the same group as nitrogen. We have oxygen, group 16. Okay, that is known as oxide. So the base name of oxygen is ox. Okay, when we add in IDE, it becomes oxide. Okay, same goes to sulfide. Okay, for sulfur, and then we have fluorine, it becomes fluoride. Cl minus the chlorine become chloride. Okay, so this is an example. Okay, name the binary ionic with invariant charge metal. Okay, so you have to identify the compound itself. First, is this ionic or molecular compound? If we ignore, okay, the description given in the question, okay, let's just have the chemical formula only. Okay, so first step is you have to identify, is this a molecular compound or ionic compound? You need to know that first, because different compound will have different naming style. So how do we know that? Okay, we have to identify that, oh, cesium come from group 1. Cesium is a metal that come from group 1. Okay, so since we have metal in the compound, automatically it will become ionic compound. So we need to follow the ionic naming style. Even the ionic itself pun, we have 2 different naming style depending on the metal in the compound. Okay, so cesium come from group 1. So group 1, we know that all elements in group 1 are having a positive 1 charge. Okay, so cesium, C is Cs plus, the cation is Cs plus. As for the anion, the fluorine, okay, this is the chemical formula of the anion, F minus. Okay, so name each compound, name each cation. So the first will be the cation and followed by anion. So cesium fluoride. Okay, all right. Checkpoint number 2, name the ionic compound formed from each of the following pairs of element. Okay, so you have to identify, uh, is this an ionic compound? Okay, regardless what we have in the question. Okay, we know that this is an ionic compound is because of the presence of this element. This element come from group 2. So this is a metal, or to be specific, it is an invariant metal, invariant charge metal. Okay, invariant charge metal. So strontium come from group 2. So we have bromine. Okay, so it become bromide, and strontium is a cation, strontium 2 plus. Okay, so make sure to name the cation first. Even though the bromine is named first here, okay, but based on IUPAC naming style, just now the cation need to be named first. So it becomes strontium bromide. Okay, all right, same goes to B. So potassium come from group 1. So potassium come from group 1. So the charge is K plus, okay? So this is the chemical formula of the cation. And then we have sulfur. Sulfur, the charge is S2 minus. Okay, all right, before that, terlupa tadi. SRBr 2. This is the chemical formula of strontium bromide. Okay, if K plus and S2 minus, it will become K2S. Okay, so this compound is named as potassium sulfide. Okay, so moving on to checkpoint 3, name the ionic compound from each of the following chemicals formula. So we have K as K stand for potassium. Okay, and then we have nitrogen, K as the anion. So K, the charge is +1, and for the nitrogen, the charge is -3. So name the cation first. So the cation is potassium, and the anion, okay, is called nitrite. The base name, dia punya apa nama tu, root name lah. Okay, root name dia nitr. Okay, so original name is nitrogen. So remove the ending and replace it with IDE. So become nitrite. Okay, and then we have B, AlCl3. So Al, we know that the charge is 3 plus. Cl, on the other hand, the charge is Cl minus. So when we crisscross this, we will get the chemical formula of the compound. So the name will become aluminium chloride. Okay. Right, so we are done with ionic compound having invariant charge metal. Okay, invariant charge metal. So now we are going for ionic compound having variable charge metal. Okay, variable charge metal. So variable charge is opposite to invariant charge just now. Okay, all right. So look at the boxes that we have here. So you may go through on your own. Okay, to simplify, let's just look at the boxes that we have here. Okay, so as you can see, the method of naming this type of compound is almost the same that what we have learned just now. The first name should come from the cation, which in this case metal lah. Okay, the metal itself, and the anion is also the same as earlier. Okay, as earlier on. So we have anion, the non-metal with the ending IDE. Okay, so the only additional info that we add in is the bracket here. Okay, is the bracket here. So we know that the metal has a variable charge. That means the charge is not fixed. Okay, so this parenthesis or the bracket, okay, the bracket represent the charge of the cation, the charge of the metal. Okay, the charge of the metal. So it should be represented in the form of Roman numerals. Okay, Roman numerals. Okay, so and one thing that I would like to highlight, okay, between the cation, the name of the cation and the bracket, there should be no gap between these two terms. Okay, there should be no gap between them. Memang format dia macam tu, tidak ada space. This one we have space. Okay, the bracket and the last name, okay, there should be space between them. Okay, all right. So let's look at example of metal cation having variable charge. So like I said earlier, most of the metals come from the transition metal. So we have chromium. Okay, chromium is one of the transition metal. So it can have more than one charges. Okay. So we have Cr2 plus and also Cr3 plus. So we have two charges for chromium. So how do we name this metal? So it should be named as chromium 2. Okay. And for the Cr3 plus, it should be named as chromium 3. So the bracket represent the charge of the metal, okay, in Roman numeral form. And same goes to iron. Okay, iron, we have iron 2 plus and iron 3 plus. So to write the name of the iron, the metal, okay, it should be iron bracket 2. Okay, cobalt, we have cobalt 2 plus and cobalt 3 plus, copper, we have tin, lead, all of this come from the transition metal. So as you can see, okay, please be aware of how to write the name of the metal or the name of the cation and the Roman numeral. There should be no gap, okay, no space between the last alphabet of the metal or the cation with the bracket. There should be no gap between them. Okay? Right. All right, so naming binary ionic with variable charge metal. Okay, so CuF2, this is an ionic compound, but it is made up of transition metal. So copper is a transition metal. Cu is a transition metal. Therefore, we need to name based on variable charge metal. Okay, naming style. So don't forget, for that naming style, we need to include the bracket. Okay, so name the cation. So the cation is copper 2 plus, and the what we call that, F is F minus. Okay, you should bear in mind that copper is a transition metal. Somehow student just forget about. Okay, dia lupa, dia tahu but they just forget. Okay, so copper should be copper 2, and then the fluoride is the anion. So when we combine these two, it become copper 2 fluoride. Okay, all right. And then we have checkpoint 4. Okay, we have FeI3 and COF2. So how do we name this? Okay, so FeI3 is made up of Fe3 plus ion, I minus. Okay, all right. So Fe is a transition metal having variable charge. So you should name it as iron. The charge is 3 plus. Okay, so iron in bracket 3, and then we have the anion as iodide. Okay, all right, same goes to COF2. So we have CO stand for cobalt. So how do we know the charge? Okay, based on the crisscross method. So this is the charge of the metal, which in this case cobalt 2 plus lah. Okay, and then we have F minus. Okay, so cobalt, it should be spelled as cobalt in bracket. Make sure there's no gap between them. Cobalt 2 fluoride. Okay, all right. Okay, yep, I think that's all for now. Okay, so we have covered the ionic compound, the naming, the nomenclature of ionic compound for both invariant and variable charge. Okay, so we will continue for the next subtopic in the next lecture. Okay, all right, thank you everyone. Assalamualaikum.